Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on configuring PAT. So let's go ahead and read our lab objective for this lab. It says Port Address Translation, or PAT, is a form of Network Address Translation, or NAT, commonly used to translate a range of private IP addresses on a local area network LAN into a single globally unique IP address on the internet, which is a global wide area network, or WAN. In this lab, you will configure PAT to enable a specified range of hosts on a private LAN to communicate with internet hosts that is configured with a public IP address. An enable secret password is configured on the ISP router and on switch A to prevent you from accessing them in this scenario. Configure the appropriate settings on router A. So if we look at our lab topology, we can see that we have 3 PCs connected up to switch A, which gives these PCs access to the network. We have switch A connected to router A, and then we have router A connected to the ISP router, and then the ISP router is connected down to a web server. Let's go ahead and take a look at some of the commands that we're going to be using in this lab. We have access list number, deny or permit, source address, source wildcard. This creates an ACL that denies or permits IP traffic from the specified address range or address range. We have configure terminal, which enables global configuration mode from previous exec mode. We have end, which ends and exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have IP NAT inside, which defines the inside interface for NAT. We have IP NAT inside source list, access list number, interface type number, overload. This translates anything matching the ACL to the IP address of the specified interface. Overload indicates that PAT will be used. We have IP NAT outside. This configures an interface to be an outside interface. We have ping IP address. This sends an ICMP echo request to the specified address. We have show IP interface brief. This displays a brief summary of interface status and configuration. We have IP NAT translation, show IP NAT translations. This displays the NAT translation table. And then we have the show running config, which displays the active configuration file. So we also have our IP address table information that Boson provides to us, which provides the interfaces, their IP addresses, and also their subnet mask. And that is included for each interface. You can see the device names. So we would definitely refer back to this table throughout the lab as needed. But without further ado, let's go ahead and get into this lab. So we're going to keep our lab topology in the top left. We're going to be doing our lab readings in the top right. And we're going to be doing all of our device configuration, which should be on router A down here at the bottom. Okay, so let's get into task number 1. It says plan for PAT. It says in this task, you review the scenario requirements, examine the current topology, and consider the configuration changes that will be needed, that will be required to achieve the scenario requirements. It says the enable secret password on router A in this lab is configured as Cisco. So number 1, let's go ahead and highlight it. It says the range of hosts on the private network that should be permitted to access internet hosts must include the IP addresses of PC1, PC2, and PC3. However, the range of hosts must also be as small as possible. What subnet of the 192.168.100.0/24 network should you use to achieve this task? How many IP addresses will this subnet provide? So let's take a look at the addresses that PC1, PC2, and PC3 has. PC1 has an IP address of 192.168.100.38. PC2 has an IP address of 192.168.100.46. And PC3 has an IP address of 192.168.100.54. So we know that our range of addresses needs to be in between .38 and .54. Okay, so I believe that's 17. I'm doing math off the top of my head, but I believe the number between 38 and 54 is 17. Let's read up on what Boson is going to say. Yep. So it says right here in Boson, the range of hosts on the private network that should be permitted to access internet hosts must include the IP addresses of PC1, PC2, and PC3. It says, however, the range of hosts must also be as small as possible. There are 17 IP addresses in the range of addresses that includes PC1, PC2, and PC3. Therefore, any subnet that includes all three hosts must have at least 32 IP addresses. Based on the 2n minus 2 formula, you could calculate a subnet with 5 host bits if 32 IP addresses are required. 5 host bits means that 5 of the bits in the 32-bit subnet mask are set to 0 and 27 bits are set to 1. The 192.168.100.32/27 subnet is the only subnet of the 192.168.100.0/24 network that defines 32 IP addresses and includes IP addresses of PC1, PC2, and PC3. Okay. So number 2, it says Cisco devices support 3 basic types of network address translation. Why is PAT the most appropriate form of NAT in this scenario? Well, PAT is most appropriate when we're doing a many to one IP address translation. So if we have a lot of internal hosts in our private network and they need to communicate with devices over the public internet, PAT will be the most appropriate because all we need is one public IP address. All of our internal hosts are going to use that one public IP address to be able to communicate with devices over the internet. Okay? So that is why PAT is the most appropriate in this situation. It says your ISP has mentioned that it is making infrastructure changes that may require you to modify the public IP address that is assigned to router A. There's a possibility that the ISP will be implementing dynamically assigned addresses. Knowing that PAT could be configured to use a pool of public IP addresses or to use a specific router interface, which configuration option is the most appropriate in this scenario? So I would say configuring it to use the don't use the pool, but use the specific router interface, because in this particular situation, it's saying that our public IP address might change. So if we use a public pool of addresses, if our IP address changes, then that could affect our devices being able to communicate with devices outside of our network. But if we use the interface, even if our IP address changes, the NAT configuration wouldn't be unaffected. So let's see what Boson is going to say. It says you should configure PAT to use a specific router interface rather than a pool of public IP addresses because your ISP has not allocated additional IP addresses for use in translation. In addition, because your ISP has mentioned the possibility of implementing dynamic IP address assignments, configuring PAT to use a specific router interface ensures that if the IP address of router A is ever changed, the PAT configuration will remain unaffected. An IP address pool is better suited in scenarios when an organization is allocated a number of IP addresses specifically for NAT. However, an IP address pool can be used in a However, an IP address pool can be used in a PAT configuration. In such a configuration, PAT will use only the first IP address in a pool unless a specific port on that address is unavailable. In that case, PAT will use the next available IP address. Okay? So let's go ahead and look at number 4. It says, do all assigned IP addresses on the accessible devices in this topology match their respective values shown in the IP addresses table? Let's take a look. On router A, let's do an enable. And it said our password was Cisco. So we type that in now. And let's do a show IP interface brief. And let's take a look at our IP address table. So router A, gigabit 00, should have an IP address of 203.0.113.1, and that matches up. Okay? And the gigabit 01 is supposed to have an IP address of 192.168.100.1, and that matches up on router A. So that looks good. Let's look at PC1. Let's do an IP config. PC1 is supposed to have an IP address of 192.168.100.38. That matches up. It has a /24-bit subnet mask. That matches up. And its default gateway matches as well. We can confirm all of that right here in the table. Let's go to PC2. Let's do an IP config. Okay. We can see that its IP address is 192.168.100.46. That matches up. The subnet mask is /24. That matches up. And the default gateway matches up as well. We can confirm that down here in the output. And lastly, on PC3, let's do an IP config. And its IP address is 192.168.100.54. That matches up. And it has a /24-bit subnet mask. And this default gateway matches up as well. So everything there looks good. So number 5, it says, examine the IP addresses table. Which devices in the network topology have been assigned private IP addresses? So if we take a look, we can see that PC1 has a private IP address. PC2 has a private IP address. PC3 has a private IP address. And also, the Gigabit Ethernet 01 interface on router A is also a private IP address. All right, number 6 says, examine the IP addresses table. Which devices in the network topology have been assigned public IP addresses? Well, we can see that router A, its Gigabit Ethernet 00 has a public IP address. The ISP, both of its interfaces, which includes the Gigabit Ethernet 00 and the Gigabit Ethernet 01, they both have public IP addresses. And we can see that this web server right here also has a public IP address, okay? So number 7, it says from router A, attempt to ping the web server of 198.51.100.10. Does the ping succeed? Why or why not? So if we go to router A and we do a ping to 198.51.100.10, this ping is successful. And it says, why is this ping successful? Well, obviously, router A must have a path to reach the web server. So let's look at this IP address table. Let's do a show IP route. And we can see that we have a static route configured. So it sends all traffic that is not included, that is not a connected or local route. It sends to this IP address, which is 203.0.113.2. And I guarantee you that is the ISP router, which it is. It's the Gigabit Ethernet 00 interface on the ISP router. And that is directly connected to the web server. So router A has a path to reach the web server. So that is why that ping is successful. Number 8 says from PC1, attempt to ping the web server. Does the ping succeed? Why or why not? Well, let's go to PC1 and let's try. Let's do a ping to 198.51.100.10. And it looks like, yep, we're getting request timeouts. And that is because PC1 has a private IP address and we're trying to communicate with the web server, which has a public IP address. So we need to configure NAT to allow our private devices to be able to communicate with devices over the internet. And we do this by configuring PAT or any type of network address translation on router A. So number 9 says, would you expect to be able to ping either router A or PC1 from the web server? Why or why not? Well, we should from the web server be able to ping router A because we just seen that router A can ping the web server. And because of that, we know that we have two-way reachability. If we didn't, then the ping wouldn't have been successful on router A to start with. But we will not be able to ping PC1 from the web server, and that is because PC1 has a private IP address and the web server has a public IP address. And we have not configured NAT on this network, so the web server will not have a path to reach PC1, and PC1 does not have a path to reach the web server, okay? So task 2 says implement PAT. It says in this task, you will make the necessary configuration changes on router A to implement dynamic NAT and to achieve the scenario requirements. The enable secret password on router A in this lab is configured as Cisco. So number 1 says the private LAN in this scenario uses the 192.168.100.0/24 address range. However, the scenario requires that only a subset of hosts within the network should be permitted to use NAT. Can a standard ACL with a single entry be used to define the host from the 192.168.100.0/24 network that should be permitted to use the NAT in this scenario? Why or why not? Well, we should be able to use a standard ACL because we are going to define the address range that will be used. So yeah, a standard ACL should work. Let's see what Boson is going to say. I think it should work. Yeah. It says the 192.168.100.0, excuse me, the 192.168.100.32/27 subnet is the smallest subnet of the 192.168.100.0/24 network that includes the IP addresses of PC1, PC2, and PC3. Because these hosts can be included in a single subnet, you can use a standard ACL with a single statement to define the host from the 192.168.100.0/24 subnet that should be permitted to use the NAT in this scenario. A deny any statement is also required in this ACL because its inclusion at the end of the ACL is implied by default. In addition, Cisco advises against using a permit any statement in such an ACL because it leads to excessive CPU utilization. Okay, so let's go ahead and get into number 2. It says on router A, create a standard ACL to define the host from the 192.168.100.0/24 subnet that should be permitted to use NAT in this scenario. So on router A, let's do a configure terminal to go into global configuration mode. And let's do a access list 1. And we want to permit the 192.168.100.32. And we want to do a wildcard mask of 0.0.0.31 because a /27 will be .31 as a wildcard bit mask. Okay. All right. So let's hit, because the regular wildcard mask, the regular subnet mask should be 255.255.255.192. So yeah, that'll be a slash. It should be a /31. Yep. So on number 3, it says on router A, issue the command to configure the appropriate inside interface for NAT. What is a inside NAT interface? Okay, so let's take a look at our IP address table. And the gigabit Ethernet 01 is going to be our inside interface. So let's do an interface for the gigabit Ethernet 01. Hit enter there. And let's do an IP NAT inside. IP NAT inside. Yep. All right. And the question was, what is a NAT inside interface? Well, that is the interface that has our private IP address. Okay. And it says on router A, issue the command to configure the appropriate outside interface for NAT. What is a NAT outside interface? Well, that should be the gigabit Ethernet 00. And an IP NAT outside interface is the one with the public IP address. So let's do an exit. Let's go into interface for gigabit Ethernet 00. Let's do an IP NAT outside. Perfect. On number 5, it says on router A, issue the IPNet inside source list command with the appropriate parameters to allow the host identified in ACL1 to access internet hosts networks by sharing the IP address of the outside interface. Use the overload keyword to ensure that PAT will be used instead of simple NAT. Okay, so let's do an exit. Let's do an IP NAT inside. We want to do a source list. We want to do the source list of 1 because that's the ACL number that we included. And we want to do a interface for the gigabit Ethernet 00 because that is our outside interface, and we want to overload it. Let's do overload. Let's say enter there for PAT because we're doing PAT. So number 3 says verify PAT. Let's go back to the lab topology. It says verify PAT. It says you have successfully completed all the previous lab. It says if you have successfully completed all of the previous lab tasks, PAT should be configured and operational on the simulated network. You should now verify that PAT is functioning correctly. So number 1 says on router A, issue the commands to display the NAT table. Are there any translation entries currently in the table? Why or why not? So let's do a N. Let's do a show IP NAT translations. IP NAT translations. And we can see that nothing is included in our table yet, and that is because we have not submitted any traffic throughout our network. It's not like we configured static NAT to where it shows in our table automatically. If we're using PAT, we have to send some information first. So number 2 says from PC1 attempt to ping the web server. Does the ping succeed? Why or why not? The ping should succeed this time because we have configured PAT on router A. So now let's try it. And yes, we're getting replies now from that web server. All right, number 2 says from PC2 attempt to ping the web server. Let's try that. Let's do a ping to 198.51.100.10. That ping is also successful. Number 4 says from PC3 attempt to ping the web server. Does the ping succeed? Why or why not? Let's try it. Let's do a ping to 198.51.100.10. And that ping is also successful. All right. So number 5 says on router A, issue the command to display the NAT table. Are there any new translations entry currently in the table? Why or why not? Well, let's see. Let's do a show IP NAT translations. And we can see all of the traffic that was generated. We can identify inside local IP addresses. This is the IP address of PC1. That's the IP address of PC2. That is the IP address of PC3. We can see that the TCP ports are used as well. And that is because we're using one global IP address. So we have to use TCP ports to identify traffic that is coming into and out of our network. Okay. And we can see the one public IP address that is being used for each of these devices. Okay. So that looks to be the end of this lab that was based on PAT. Let's hit grade and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I will see you in the next one.